Hey, good morning, everybody. Welcome to our GRE Quant concept series class, mean, median, and mode. We were supposed to do this yesterday, but then we did charts practice instead. So if you were looking forward to this yesterday, I apologize. But this stuff that we're going to talk about today is important. I think the mistake that a lot of people make with data is they focus on probability, standard deviation. They focus on, combinatorics. That kind of stuff does show up, but it's relatively rare. Mean, median, mode, range, charts, that kind of stuff just shows up everywhere. Just shows up everywhere. So with that said, let's get into it. Oh, how's everyone doing, by the way? Today's Friday, right? Yeah. Any weekend plans? GRE, none, practice test, GRE as usual, movie, stay at home, baby shower, movies, holiday shopping, going to have a surgical extraction of my wisdom tooth. I think you win there. That probably sounds like the best weekend activity. So that's cool. All right, so here we go, everybody. So our table of contents, we are now in data analysis. We've already talked about presenting data. So here we are getting into the describing data. Now, describing data means how can you talk about data in an efficient way? Because if you take, for example, 5, 7, 11, 13, 15, 19, 24, 27, do I want to always list out all of these numbers when I describe this data? No, because it's just inefficient, it's too time consuming. So we have created techniques that allow us to talk about this stuff faster. Some of those techniques, they're called mean, median, and mode. All right. Let's talk about the mistake. What mistake do you guys think people make about mean, median, and mode? All right, I'll give you guys about a minute to think about it. All right, here's the mistake. You guys assume it's easy. You guys go through the GRE math review guide and you're like, oh, this is easy. Give me that probability. Give me that combinatorics. Right? Like, it's almost like if somebody asks you, do you know how to find the mean of a set of numbers? Maybe somebody would get offended. Like, of course I know how to do that, right? But the GRE is not easy. And what they do is they distort these concepts, or they test kind of some nuanced stuff about these concepts that maybe you guys are not familiar with. So basically, we are going to try to show you some of those nuances. We're going to show you some of these tricks, and then maybe you will have a greater appreciation of mean, median, and mode once this class is over. So is it actually easy? I think you can answer this question just because I've been leading up to it. The answer is not really. And I want to give you a couple of examples. Is this an easy problem? No, this is a very, very difficult problem. But look, they're just asking me about average and median, right? So why is this such a hard problem? If you actually calculated the average and the median here, it would be an extremely time-consuming process. Maybe like 4 to 5 minutes, something like that. So this is a question that ETS has labeled as hard. And if I had to guess, if people didn't know the trick, which we will talk about shortly, if people didn't know the trick, my guess is maybe 15% of people would get this correct. Something like that. It would be a very low number. It'd be a very low number. Okay, so that's one example. Here's another example. Take your time, read this problem. This is a GMAT problem, by the way. So take about a minute or so. So this is a GMAT 700 level problem. If you guys are familiar with GMAT 700 level, are these easy or difficult? Yeah, these are tough. These are difficult. All right, so here's another example where average and median and all that stuff, not that easy. I think I have one more example here. Okay, go ahead and read this problem. Take about a minute or so. So this one says, at a certain fruit stand, the price of each apple is 40 cents and the price of each orange is 60 cents. Mary selects a total of 10 apples and oranges from the fruit stand, and the average of the price is 56 cents. And then it asks you, how many oranges must Mary put back so that the average price of the prices of pieces of fruit that she keeps is 52 cents? If you know the trick here, it's a relatively straightforward problem. If you don't know the trick, you're going to get lost in the algebra or lost in just choosing numbers and guessing. So I really want you guys to take away from this, I need to understand mean, median, and mode so fully and so completely that when I come across a really difficult problem, such as the three we just looked at, you can knock it out of the park. Okay? Sound good, everybody? We do have a question from Sankita. Hey, what's up? Oh, she put her hand down. I assume that was an accident. All right, so let's talk about the basics. I think you guys know all the basics, right? So how do we find the average of these 5 numbers? Maybe take about 30 seconds or so. So the average of these 5 numbers, the first thing you would do is you would, remember the formula. Oh, and I don't think we've mentioned this yet. Average and mean, they can be used interchangeably. Do you guys have a preference? I typically say average. I'm more of an average guy myself, right? But they do mean the same thing. Average and mean are equal to each other. Okay, so the formula is the sum of the numbers divided by the number of the numbers. So in this case, what is the sum? 7 plus 5 plus 8 plus 4 plus 1, what is that going to equal? Yeah, 25, right? And then how many numbers do we have? We have 5 numbers, and so the answer is 5. A lot of you guys think, okay, I know this, I know mean, I know average, let's move on to probability. Do you think GRE will ask you an average question like this? Hey, find the average of these 6 numbers, right? So you, like I said, you have to have a much more nuanced understanding of it. All right. Here's a pro tip, everybody. Pro tip. Whenever you do an average problem and the average is given to you, what should you immediately calculate? Immediately calculate the sum. I don't care if they're not asking for the sum. I don't care if you don't see the sum anywhere in the problem. Immediately calculate the sum. So if you're given a set of numbers and told it's average, immediately do the calculation of finding the sum. The sum is important in many average questions, especially in more difficult ones. So if you have that number always at hand or on hand, you'll get more questions correct. Okay. Somnia, how do you stop the chat notifications? I think you'd have to Google that. Does anybody know how to stop the chat notifications? Oh, so keep the window and shift it out. Does that only work if you have 2 monitors? Press Alt. Somebody says press Alt. Move the window to a corner. You can pop out the chat, no need for duels. Okay. So everyone, hopefully you can find some technique there, right? So I want to keep the chat for those who want to use it, but if it's bothering you, I do want you to have a method for it to go away. So hopefully you can figure that out. All right, here's a couple of examples of finding the sum. All right, so everyone, really quickly, what's the sum here? 320, right? Does it actually tell me to find the sum or no? No. But would the sum be useful in solving this problem? Yes, it would. So everyone, go ahead and solve it. I'll give you guys 30 seconds, a minute. Okay, so the sum is going to be 320. Let's write this down. So 320, I already have 90 and 60, so let's take those out from the sum. What is that going to equal? 170, right? Everyone agree? And then finally, that means the other two donations have to add up to 170. And so you do 170 divided by 2, and that's going to equal 85. And of course, 85 is bigger than 80. Correct answer is A. Okay, so that's one example where I want you to immediately calculate the sum. Here's another example. Really quickly, take about 30 seconds. Don't solve the problem, just tell me what the sum is. Yeah, $5.60, right? So 10 pieces times 56 cents is going to equal $5.60. Now, this number actually doesn't help you that much, but what I want you guys to do is to get into the habit of just immediately calculating the sum. What if you're given the sum and the number of items? What should you immediately calculate? Immediately calculate the mean, right? So it goes both ways, right? Just get into this habit. I'm a big believer in habits. Do you guys know my habit for ratio problems? So every time I do a ratio, if they say the ratio is 2 to 3, what is my habit? I like to list out all other possibilities, like 3 or 4 more possibilities. So wouldn't 4, 6 be the same ratio? Wouldn't 6 and 9 be the same ratio? Right? Wouldn't 8 and 12 be the same ratio? Stuff like that. So whenever you get into these habits, you're much less likely to fall into traps or to just like stare at a problem not knowing what to do, right? Yep. Here's one more example. How would you find the sum here? Yeah, it would be 27 times k, right? And then what can k equal? Can k equal 10, yes or no? Can k equal 10.1, yes or no? Are you sure? Read carefully, everybody. Read carefully. Can you have 10.1 numbers? Is that possible? How do you have 10.1 numbers? All right, listen, I need 10 numbers and I need a tenth of one more number. Right? So doesn't that mean that this has to be an integer? So what is the smallest k value that would work? The smallest k value that would work is 27 times 11. And there you go, you're calculating the sum. Compare that to 300, everybody. What do you get? Yeah, you get 297. Now, of course, it could be bigger than this, right? It could be 12, for example, etc., etc. All right, so we're not solving these problems, so don't worry about that. What I'm telling you is just get into the habit of immediately calculating the sum. It will save you a lot of time. So before we move on, does anybody have any questions so far? Nope. Okay, let's move on. Let's talk about median. How do you find the median? What's the process? Oh, we do have a question from Navia. Hey, Navia, what's up?
Hi, I was actually confused by the fact that we assume number to be integer.
Can you have 10.1 numbers?
Um, yeah, maybe this source is not correct, but in one of the Manhattan 5 LB question that I did recently, they assumed that a number can be fraction. Maybe I need to
Oh, a
go
number
back.
could definitely be a fraction, no doubt about it. 1/2, 1/4, 1/7, 1/10. But how many numbers do I have here?
Okay. Okay, I
So
get you.
how many numbers total?
Yeah, that's 4.
4 total numbers, right? So can you have 4.1 numbers? Or 4.2
Okay.
numbers, right? Does that make sense?
Yeah, yeah.
So
That
a
makes sense.
number can definitely be a fraction, no doubt about it. A number can be an integer or a fraction or an irrational number, but whenever you're talking about the number of numbers, it has to be an integer, right?
Yeah, yeah,
Yeah,
that
cool.
makes sense.
Hey, Serena,
Thank you.
question?
Oh no, I wanted to reply to answer to your
Oh,
question.
oh, okay, sorry. Did I answer it or did you want to add something?
No, I wanted to answer your question. You asked how to find a median.
Oh, sure. Okay. How do you find the median? Thank you.
So you arrange the values in ascending order,
Mm-hmm.
and then if the number of the values is even, the median will be the two middle values, the sum of the two middle values divided by 2.
Which is the
And
average, right?
yes.
Mm-hmm.
And if the number of items is odd, the median is the middle value.
Yeah, so what's easier, odd number of values or even number of values?
What is easier?
Yeah, what's easier to calculate?
Odd.
Yeah, odd is definitely easier. But I think in your mind, you're saying both are easy, right?
Yeah.
Yeah, she's like, well, that's a stupid question. Both are easy. No. But yeah, Serena's absolutely correct. So what you want to do is you want to label them in ascending order. So from low to high, 1, 4, 5, 7, 8. If the numbers are odd, it's actually quite easy because all you have to do is identify the middle number, which is 5, right here. So let's go ahead and look at one kind of slightly more complicated case. If you have an even number of numbers, everyone can see we have 6 numbers here. You still want to put it in ascending order, 1, 4, 5, 7, 8, 9. But the difference here is, do I have a true middle number? No, right? Because if you choose 5, you have 2 over here, but you have 3 over here. So that is not a middle number. If you choose 7, you have the same problem, but the other way. So what do? How do we solve this problem? We find the average of the two middle numbers. What's the average of 5 and 7? 6. Now let's have somewhat of a meta discussion here. What is preferred, median or average? I would say in many cases, you'll see that people prefer the median, and I'll explain why. Let's imagine we put all of ourselves in a room. What do you think the average salary would be of all of us in a room? So let's say we have 50 people in a room. Let's just say the average salary of everybody is $10,000. Some people make less, some people make more, but it's a relatively consistent value, right? Maybe the high range is 100,000, maybe the low range is 0 because the person's a student, but it's a pretty relatively consistent range. And let's say we have 50 people in the room. What would happen if, oops, not 50 billion, 50. What would happen if Elon Musk walked into the room? What would happen? Would average be a good indication of everybody's salary? No, because it would probably look like that everybody's net worth was like, everyone would have a net worth of $3 billion. Like, wow, there's 50 billionaires in that room, right? But of course, that is an invalid figure. Now, if we brought Elon Musk into the room, would the median change that much or just a little bit? The median would change just a little bit. So you often see a lot of organizations and people who deal with data. In many cases, they prefer the median because it tends to not suffer from those outliers. Okay. Any questions about that? All right, let's move on. Mode. What is the mode? Yeah, the mode is just the most common number. So everyone, take a look. What number do you see most common? Yeah, it's just 5, right? However, this is a little bit tricky, but not really. It's just slightly more complicated. What would you do in this case? Can you have 2 modes is my question. Yes, you can. Yeah, you can have 2 modes. It's not common, but it is something that can occur. So in this case, you just have 2 modes. A word that we use for that is bimodal. Okay. Any questions about this? See, this is when you guys get into your false sense of, this is easy. Oh my God. Give me the probability. Give me the combinatorics, right? But remember, ETS and GMAT have a way of really making this stuff a little bit tricky. All right. So let's start getting into that, right? Before we do, just do me a favor, calculate the mean, the median, and the mode. I'll give you guys about 2 minutes. Feel free to use a calculator. Okay, first thing we want to do is put in ascending order, which is going to be 68, 68, 72, 72, 72. I think we have 3 of those, is that right? Then it looks like we have a 75. Then it looks like we have an 81, right? Then it looks like we have an 85. And then it looks like we have 2 91s and 1 92. Does everyone agree with this order? Okay, did I miss any numbers? 95, exactly. There we go. Thank you so much. So we should have a total of 12 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, cool. All right, so let's do the mode, because that's obviously the easiest one. Which one of these numbers do you see appear the most frequently? Yeah, the mode is 72. Okay, let's now do the median, because that's the second least tedious one. So it's going to be the average of the 6th and 7th number. So this is the first number, the second, the third, the fourth, the fifth, the 6th, and the 7th. What is the average of 75 and 81? It's going to be 78. And then finally, if you used a calculator, what was the average? I got 80.167. Did you guys get that? Something like that? Or 80.17? Yeah, something like that. Yeah. Okay. In this set of numbers, does median equal average? No. So now we are starting to get into that nuance that I'm talking about. When does mean equal median? Now don't tell me the answer. Let's see if people can figure it out. So let's keep the chat box quiet. Okay, this is a very, very powerful concept. You have to know this. Okay, don't answer it yet. What do you notice about these two sets of data? Don't say in the chat box. Give everybody a chance. So let's keep the chat box quiet for like 1 minute. What do you notice about this set of data and this set of data? Take about a minute. All right, Natalie, what do you notice?
It just increased by number 3.
Okay, so this is a gap of 3 plus 3 plus 3 plus 3 plus 3 plus 3. So would it be fair to describe this set of data as evenly spaced?
Yeah.
Would it be fair to describe it as symmetrical?
Meaning on the XY axis?
Exactly. If you put on the coordinate plane, would you describe this data as evenly spaced or symmetrical?
I think it's evenly spaced.
Okay, now look at number 2. What do you notice about that? If I were to draw a line right down the middle.
Symmetrical?
Exactly, right? So in both of these cases, everybody, mean equals median. If you don't believe me, I want you to use your calculator to prove it. So first of all, let's look at the median here. This set of data, what is the median? Okay, so 5, 8, 11, 14, 17, 20, 23. We have 7 numbers. What's the middle number? 14, right there. What I want you guys to do now is use your calculator and find the average of this set of data. It should blow your mind. Okay, is the average 14? Pretty cool, right? So I think you might be asking, you know, cool trick, why do I care about this? Because so many GRE and GMAT problems rely on this trick. So many of them. Take, for example, this problem right here. If the average of 5 consecutive integers is 12, does that mean evenly spaced, yes or no? So immediately, I just go like this. 9, 10, 11, 12, 13, 14. I can do the problem in 2 seconds. Right? Because it has to be 5 consecutive integers. The average has to be 12, which means I know 12 has to be in the middle because mean equals median. So it takes 5 seconds. And of course, what are they asking? They're asking for the, what? The sum of the smallest and the biggest, right? So what's that going to be? 10 plus 14, right? 24. Okay. Let's look at another one. How about this one? Why would this trick help me? Okay. Take about a minute or so to think about it. All right, if I wanted to make things easy on myself, I want to make my life easy, what K number would I choose? Not 9. You would choose 12. Now let's analyze why. If you have 6, 9, and 12, and this is the k value, what is the median? The median equals 9. What is the average? Equals 9. Do I have to do any calculation whatsoever? No. So this would save me about 5 to 10 seconds. It's not like, it's not like blow your mind, you save so much time in the world, but, you don't have to actually do any calculation, which is kind of nice. So in this case, now that you have numbers, you have k equals 12 and n equals what? N is going to equal 9. You plug this in, see which one of them gives you k. So which one of these gives you k? Right? So for example, 3 times 9 is 27. 27 minus 15, isn't that 12? Okay, so that's another example where you can use that trick. How about this one? How about this one? The first 7 positive integers, 1, 2, 3, 4, 5, 6, 7. Now you could do this. You could go 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 22, 22 plus 7 is 29. Okay, 29. Right? And you would get the wrong answer. Or you would get the right answer, it would be very time consuming. This is an evenly spaced set. What is the average? 4. What is the median? 4. Now, I know the average. I know the total number of numbers. Could I find the sum from that? Yes or no? Sure. So you just do average times the number of numbers. The average is 4. Times it by the number of numbers, which is 7, 28. Now look at quantity B. 7 times the median. What's 7 times the median? Yep, 4 times 7 again, so 28. Correct answer is C. So what is ETS testing here? They're not testing your ability to get this wrong. They're testing your ability to not waste time. They're testing your ability to not waste time. So Somya says, can you please repeat the trick? The trick is this. Whenever you have an evenly spaced set, so notice how the gap here is 1, 1, 1, 1, 1, 1, 1, the median equals the average. And if you have the average, you can very quickly find the sum, right? Okay, let's go ahead and take a look at another one. How about this one? Everyone, read this question for a minute and tell me how the median equals average comes into play here. Okay, what information did they give me? Did they give me the shortest side? Yep. Did they give me the longest side? Yep. Did they then ask me about the middle number? Yes or no? Yep. And they said the middle number is equal to the average. Oops, sorry, 6, my mistake. Thank you. They said the middle number is equal to the average. Isn't that just another way of saying average equals median? Right? Isn't that just another way of saying this? So, what is this going to be? 8. Now, I actually was kind of nice to you guys because I gave you numbers. What if I gave you no numbers? What if I said a right triangle has a hypotenuse and the shortest leg and the medium leg? The middle leg is the average of the shortest and the hypotenuse. So that's a much harder problem, right? But you should immediately realize we're dealing with what kind of right triangle? We're dealing with a 3, 4, 5, right? We're dealing with a 3, 4, 5. So this is 5, this is 3, this is 4. But remember, because this is a ratio, it could also be a what? A 6, 8, 10. So I was pretty nice to you guys because I gave you the numbers. If I didn't give you the numbers, you might think that this problem is not solvable, but indeed it is solvable, because what if I said, for example, what is the least area of the triangle? Or something like that, right? And assuming they're all integers, right? So, you know, they can make these problems a lot harder if they want to, right? By just kind of withholding information. All right, let's look at another one. How about this one? Everyone go ahead and give this one a shot. Okay, let's just ask ourselves a couple of questions. Is this an evenly spaced set? 3, 6, 9, 12, 15, right? How many of these multiples of 3 do I have? From 1 to 100? 33. And then couldn't I take the number of numbers, which is 33, and multiply it by the average to get the sum? And I know the average equals the median. So, how do we find the median? There's actually a trick. What is the first multiple of 3? 3. What is the last multiple of 3? 99. So here's the trick. You do last plus first divided by 2. Last plus first divided by 2, which basically means the average of the first and the last number, right? So what do you get? You get 102 divided by 2 times, oops, sorry, what does that equal? 51. Okay, does everyone understand this trick? So now I have the median. Does the median equal the average? Yes or no? Yes, it does. So 33 times 51. I don't have a calculator. What does it equal? Yeah, 1683. Now, a lot of you guys are asking, how did we get the number 33? Okay, good question. When you have the numbers 1 through 10, how many numbers is that? 10, right? Now, you just know that from memorization, but do you know a formula that can give you that number? Can't you do the last number minus the first number and then plus 1? Right there. So what you get is 10 minus 1 plus 1, and you get 10 numbers right there. So let's do this. What is the last multiple of 3? 99. Minus the first multiple of 3, which is 3. Don't forget to divide by 3 because that's the multiple we're talking about here. For example, we don't have 96 multiples of 3's, right? So you have to divide by 3, and then don't forget to add 1. What do you get there? You get 96 divided by 3 plus 1, and then you get what? 32 plus 1, 33. All right, so this is a very important concept, so let's change this a little bit. What are the multiples of 5? From, let's say, 100 to 200, inclusive. Okay? Everyone go ahead and give that a shot. I'll give you guys 90 seconds. All right, first of all, is this an evenly spaced set? So we have 100, 105, 110. All right, what that means is median equals average. What is the median here? I think in this case, we could just eyeball it. What's the middle number between 100 and 200? Yeah, it's going to be 150, right? So 150 is the median. And then finally, what is the average? The average is 150. It's the same. So the last question we have to ask ourselves is, how many 5s do we have from 100 to 200? So let's do the formula. So the last multiple of 5 is 200, minus the first multiple of 5 is 100. Don't forget to divide by 5. If we don't divide by 5, then this result would be something ludicrous. It means we would have like 100 multiples of 5 from 100 to 200. Makes no sense, right? Makes no sense. And then finally, plus 1. If you do that, what does it equal? It equals 21. So here's the final calculation. 150 times 21. I don't know what that equals. Do you guys have a calculator? Yeah, 3150. Okay. Let's look at one more problem to illustrate this concept. So this is that famous problem, right? So check this out. Imagine I eliminate these 4 bar columns. Is the data symmetrical, yes or no? Right? It's symmetrical, right? If you look to the left of the middle and to the right of the middle, it's symmetrical. It looks like somebody's giving you the middle finger, right? So let's actually write down some data here. Tell me if this data that I produce kind of matches what we see here. So 5, 10, oops, hold on, let me erase that. All right. 5, 10, 10, 10, 10, 15. Now, this data is not evenly spaced, but is it symmetrical? Yes, it is, right? Do you agree that this data somewhat matches what I've produced over here? So we have one small column, one small bar of 5. We have a big bar of 10s, and then one small column of 15. So here's the question. What happens if I add in one of these bars right here? So right now we've eliminated them. Let me erase it. So let's imagine I bring this bar into the mix, and we call that number 16. Does the median change? The median is still what? The median is still 10, but does the average get bigger or smaller? The average gets bigger. So what's the answer? A or B? What's bigger, the average or the median? Yeah, the average. So that's the trick. That's the trick. So just imagine that this data is symmetrical. If it's symmetrical, we have mean equals average. The correct answer would be C, right? But if you start bringing in these other numbers right here, 1620, 2125, 2630, 3135, its effect on the median is actually quite small because we have such a huge group of numbers right here, right? Maybe the median wouldn't even change, right? The median might stay very close to what it originally was. But every time you add these numbers, what happens to the average? Yep, it gets bigger and bigger and bigger. Okay, so let's do that again because this is a very important concept. Imagine these 4 bars don't exist. What is the answer to this question? C. Okay. Imagine I bring this bar into the mix. Did the median change? No. Did the average change? Yes, it did. It got bigger, right? So the correct answer has to be this one. Okay, let's show you that with data. So imagine we have a small column of just 5. Imagine we have a lot of 10s. We have 5 10s. And then finally, we have another small column of 15. Do you agree that this kind of matches the chart right here? So we have the small column, the big column, and the small column, right? If I bring in another bar right here, so let's say 16, does the median change? No, the median is still 10. 10 is still the middle number. Does the average change? Yes, the average is now bigger than the median. And what is this question asking you? It's asking you to compare the average to the median, so the answer is A. Does that make sense? What happens if the chart looks like this? Right here. The tail is over here. Would the average be equal to the median or less than the median? Yeah, the average would be less. So here's the rule that you have to remember. Follow the tail. Average follows the tail. If you look at this picture right here, where's the tail? Is it on the right or the left? The tail's right here. It's on the right, which means average is bigger than median. If the tail is on the left, like in this case over here, average is less than median. Somebody in the chat box asked, why did the median not change? Well, we can actually do that with data, right? We can actually show you with a set of numbers. If you have 5, 10, 10, 10, 10, and 15, we all agree that this is symmetrical. If it's symmetrical, that means that median equals average. If you don't believe me, go ahead and test it. All right, everyone, go ahead and confirm that. Go ahead and confirm that median equals average. Okay. Did we confirm it? All right. So we know that the median is going to be the average of 10 and 10, which is 10. And did you guys do the average calculation? The average calculation, right? It brought you to 10, right? Okay. What if I add in the number 17? What is the median? The median is still 10. Now, on your calculator, go ahead and calculate the average, everybody. Use your calculator. What'd you get? Yep. So, what's bigger, average or median? Average. So what do we choose, A or B? A. Okay, let's do one more example. What if I put the number 3 here? So now the tail is over here. Okay, go ahead, use your calculator again, calculate the median and the average. So the median still equals 10. What does the average equal? Average equals 9. And now average is less than median. Now somebody said, but these are not evenly spaced. And you are correct. They are not evenly spaced, but they are symmetrical. Remember, symmetrical or evenly spaced, they both work. So again, take our numbers, 5, 10, 10, 10, 10, and 15. If I were to put a mirror right here, right down the middle, imagine this is a mirror. If you look to the left and look to the right, do you see the same thing? Yeah, you see 5, 10, 10, and then 10, 10, 15, right? Okay, so this is a symmetrical data set. So whenever it's symmetrical or evenly spaced, median equals average, which allows you to do a lot of tricks, right? If you don't understand this, just remember that average follows the what? Just remember this. Average follows the tail. If you look at our diagram, the tail is on the right, which means the average is bigger than the median. But if the tail were over here, average would be less than the median. Or, alternatively, you can calculate it. If you calculate it, it would be nasty. It would, like I said, it would probably be 4 to 5 minutes of calculation. Yeah. Paratosh says, how were you able to find the average from the graph? It's not that I know exactly what the average is. I just know that the tail is over here. And whenever the tail is over here, I know that average is greater than median. Right there. What if none of the data is symmetrical? You are now asking hypotheticals that ETS is unlikely to test. Does ETS want to waste your time, or do they want to test your ability to find shortcuts? Yeah, they want to test your ability to find shortcuts. Right? Cool. All right, let's take some questions. Question from Moses. Hey, Moses.
Hello.
Hey.
So I just wanted to know if this method works if the y-axis isn't frequency.
No, because whenever we're talking about average, we need to know the number of numbers, right? So if you don't have frequency, how would you know that, right?
Yes.
Mm-hmm. Good question. Okay, let's go to Sumeta. Hey, Sumeta.
Yeah, so I wanted to ask if we add, say, like 3 or 4 numbers to the right, wouldn't the median change in that case?
Yeah, but the average changes faster. So yes, it is possible for the median to change. It's 100% possible. But notice it would only be shifting into this column right here, whereas the average would have already shifted like way over here. So ETS is not going to give you a question that is like so tricky that you learn the fact that average follows the tail, but then ETS constructs a chart where actually the tail is misleading you. ETS would never do that. Yeah.
Okay.
Make sense?
Yeah.
Good. So real quickly, somebody's asking, does symmetrical depend on frequency? Like 3 numbers to the left, 3 numbers to the right. So 5, 10, 10, mirror, 10, 10, 15. Symmetrical or not symmetrical? This is symmetrical, right? Because think about it. The median is 10. This is plus 0, plus 0, minus 5, plus 0, plus 0, plus 5. What happens to the minus 5 and the plus 5? They cancel out, right? They cancel. What about if I change this to 4? Is this data symmetrical? No. So think about it that way, if that helps you. Okay. So here's my final question. This data, is it evenly spaced? No, but is evenly spaced data symmetrical? Yes, it is, right? Okay, cool. Let's move on. Here's a pro tip, everybody. We already talked about this. Finding median quickly in an evenly spaced set. All you have to do is the first number plus the last number divided by 2. If you know that your data is evenly spaced, there is a cool and fast trick you can use to find the median. Simply add the first and last numbers together and divide by 2. Of course, this is also called the average. We call this the average, right? Of the last and the first one. All right. There is one more thing that we have to talk about. Weighted average. We talked pretty in detail about weighted average in the algebra class on applications. So if you are curious in finding more about this stuff, go to the GRE Quant Concept Series class, look at applications. You can see a lot of information about weighted average, but I just want to give you a little bit of a rundown of what weighted average is. If you take a look at this tug of war, imagine that average is tug of war. And imagine this guy on the left is a 6, this person's a 6, this person's a 10, and this person's a 10. Where would it happen? Like, where would the average be? Yeah, the average would be right here, right in the middle, right? And the reason why is because what is the distance from 8 to 6? Minus 2, minus 2, plus 2, and then plus 2. So if you add all of this together, is there an effect on the left or the right, or do they cancel out? They cancel out, which means the average is going to be right in the middle, okay? But what if I were to do this? Add this guy on the right. What if I were to add this guy on the right? What would happen to the average? The average would shift left or right? It would shift right, like that. And then the average would be what? I don't know, something like 8.5 or 8.7 or something like that. Yeah, he's not holding the rope, but he's using mind power, right? This is a Marvel superhero. All right, so he's shifting the average to the right. So whenever you think about weighted average, think about what has more pull. What can pull? I'll give you an example to show you what I mean here. Okay, everyone read this problem and then tell me what has more pull. So we have a share price that costs $9 and a share price that costs $10. If everything's equal, what would the average be? Just imagine everything's equal. Yeah, the average would be 9.5, right? The problem is, how much money did I use on the $9 side? I used $4,500. How much money did I use on the $10 side? $3,000. Which side is stronger? The left side or the right side? The left side. So what happens to this average? It goes toward the left. So immediately, can't I cross out two of these answers? What two can I cross out? Yep, A and B, immediately out. Okay, we don't need to solve it. You just need to understand that concept. Does that tug of war make sense to you? How it's kind of pulling it to one side? Okay. Here's another example, right here. Try to do this problem, everybody, and then I'll show you a really cool trick. All right, can I have a volunteer walk me through this? All right, let's go to Natalie. Oh, actually, I already called on you today, Natalie. Sorry, I don't mean to. Let's go to Sodab. Hey, Sodab, how's it going?
Hi, Greg. It's going good.
All right, so how would you do this from a weighted average perspective?
So if the number of boys and the number of girls are equal, I'll just take the weighted average number would be 85.5.
Right. If you have an equal number of girls and an equal number of boys, it would go straight down the middle and it would be 85.5. But where is the true average?
It's 84 towards the left.
So it shifts to the left. So does that mean we have more girls or more boys?
More girls.
Yeah, we have more girls. The girls are more powerful. So the correct answer in this case would be A or B?
It's B.
Okay, now are you guys ready for a trick that will blow your mind? Okay, not only can we say with confidence that the number of girls is greater than the number of boys, we can actually find the ratio very quickly. So we have the average for the girls is 81, the average for the boys is 90, and then 84 is the combined average. What is the distance from here to here? 3. What is the distance from here to here? 6. So we have two possibilities for the ratio, so girls to boys. It could be 3 to 6 or 6 to 3. Do we have more girls or more boys? Remember, we have more girls, so don't say the ratio is 3 to 6. That doesn't make any sense. So the ratio is actually 6 to 3 or 2 to 1, right there. So whenever you use this trick, do not forget to flip the ratio. You have to flip the ratio. If you don't flip the ratio, it doesn't make any sense. It would say that there's more boys than girls, right? So I want you guys to test this. If we have 10 girls, how many boys should we have according to our ratio? 5 boys. I want you to actually confirm with a calculator that the combined average would be 84. Go ahead, let's confirm it. I'll give you guys about a minute. Okay, so what is the combined score of the girls? So 10 girls, they each get an 81. What is that? 810, right? What is the combined score for the boys? It would be 5 boys, they each get a 90. What does that equal? 450. And then finally, what do we divide by? How many total people are we talking about? 15. And does that equal 84? Yes or no? Yes. So if you want to solve mixture problems and ratio problems very quickly, you can use this little trick right here. All right, we have a question from Tim Tam. Hey, Tim Tam.
No, hey, Greg, I wanted to volunteer at that time, but I forgot to load.
Oh, sorry. I stole your thunder. Apologies. All right, there is one more thing I want to talk about. One more thing. Okay. The effect of mean and median on range. All right. What is the effect of mean and median on range? Let's go ahead and take a look. So this right here is a very, very difficult problem. Most people get it wrong. All right. So everyone read the problem so we're all on the same page. Okay, are we all on the same page here? So they give me information about the range, and then they ask me a question about the combined range. And let's look at the information they gave us. So they gave us, if you look at A, the tallest male and the tallest female, let's ignore that for now. Let's focus more on B and C, the median and the average. Do you see these numbers 1, 3, 5? What is the median, average, and range? Okay, so the median is 3, the average is 3, and the range is 4. Okay? How about these? What is the median? The median is 2. The average is going to be what? So it looks like 9 divided by 3, which is going to be 3. And then finally, the range is 5. So you might think from this example that when you change the median, the range changes. Or when you change the median, you know, the average changes, whatever. You might think that they all influence each other. And sometimes they do. They sometimes do influence each other. But look at this one right here. 125. What is the median? 2. What is the average? 8 divided by 3, right? And then finally, what is the range? 4. So everyone, take a look. I've changed the median. I've changed the average. The median is now 2. The average is 8 over 3. Has the range changed? No. So as long as I leave the first number and the last number intact, I don't change them. Do mean and median influence the range? No. So here's where we get into this question. If they give me the average, is that enough information to determine the combined range? No, I have no idea. How does this help me? What if it's a bunch of middle numbers? Right, that doesn't help me. If they give me the median, is that enough information to confirm the combined range? Nope. And then finally, even if you don't understand why, you have to choose something on the GRE, right? Can I leave all 3 of these blank? Or do I have to choose at least one? You have to choose at least one. So right there. So this is what I mean by mean, median, average, range. All this stuff is a little bit more complicated than people give it credit for. So we talked about a lot of stuff here. We talked about the basics. We talked about weighted average. We talked about when a mean equals a median. We talked about the tricks that we can do with that. You know, all these little shortcuts. And then finally, we talked about the influence of mean and median on range. If you're just changing the middle numbers, the mean and the median will change, but the range will not. Cool? All right, this class is already 10 minutes over. We will be doing a practice session, I believe, next week. I hope you guys enjoyed that. All right, talk to you guys later. Bye-bye.